Hello everyone, this is Korada Vishali, and today the topic on which I'm going to teach you is a brief introduction to matrices, their types, and their basic operations. Right? So, I will be giving an introduction to what matrices are and what are their types and what are the basic operations that we do in matrices. So, now the first question that might be coming into your mind is, why do we need it? Why do we need to study matrices? Right? So, the basic concept is that we in this world deal with large data, which is, we can say that they are complex, right? So, now what matrices do is that they help us to represent the data into a simple, understandable form. So it helps us to just break down the complex data into a simple form, right? So this concept of matrix is not only used in simplifying the data, and it is also used in solving complex linear equations. And along with that, it is also used in many fields, let it be business and economics. So now this gives us enough incentive to basically get to the definition, the next part, right? So what are matrices? Okay, so that is the main question that we must have in our minds. So a matrix is a rectangular ordered array of numbers or functions. Now each and every word has its own significance. What I mean by rectangular is that I will just give an example of a matrix. I will just write a random matrix. Let it be A, B, C, D, E, F. So this is what generally a matrix looks like. Now what do I mean by rectangular is that it seems as if this matrix has a length associated with it and a breadth, isn't it? Right? So that is why we say that it is somewhat rectangular. Now what I mean by ordered is, every matrix has a order associated with it. Okay, so first of all, let's focus that what do we mean by order of a matrix. So generally when it comes to the representation of a matrix, we denote it as in square brackets, and Aij are the elements. Basically, like if I were to just go through this matrix, so A, B, E, C, D, F. So these are the elements which we just denoted as Aij, and in the subscript we write this M cross N. Now what is this M cross N, right? This might be the next question that must be coming into your mind. So M is the number of rows and N is the number of columns in the matrix. Okay, so let me just give you an example. I have 1 2 3 4 5 6. Okay, so this is my matrix. Now observe, this seems to be my first row, right? First row, and this seems to be my second row, isn't it? And if I were to consider the column, this is my first column, this is my second column, and this is my third column. This is my second, this is my third column. So now what will be the order of this matrix will be? It will be number of rows with the sign of multiplication. Then we just mention the number of columns. Now in this case, how many rows are there? There are 2 rows, the sign, multiplication sign, with the number of columns, right? There were 3 columns in which we have just explained here. So this is how we define the order of a matrix. It's just simply the number of rows multiplied by the number of columns, right? Now let's just come back to the definition of matrices. We just explained that, I have just explained that what do we mean by rectangular, right? And what an order is. Order is simply the number of rows multiplied by the number of columns. Okay, now the next thing which comes is that it is an array of numbers. Now array of numbers or functions, it can be an array of numbers and functions. Now array, just simply by definition, it means that it is a collection of numbers, or it can be function. Now the example which I have just explained before, this is a collection of numbers. Like we have 1 2 3 4 5 6. So this is kind of a array of numbers. Now what about functions? Now what if I just make a matrix like 1x sin x cos x. First of all, focus what is the order here. This is my first row, this is my second row. The number of rows is 2. Right, and this is my first column, and this is my second column. So number of columns is 2. So the order will be 2 cross 2. I hope you're getting it. Now what is this? 1 is a number, x sin x cos x. Now these are functions, right? We know that. So now this is an example of a collection of numbers and functions. Okay, so I hope so the definition is pretty much clear, that a matrix is a rectangular ordered array of numbers and functions. Okay, so now what is the next thing? Is creation of a matrix. How do we generally form a matrix? Then how to find the elements that belong to it. Okay, so for example, I will just give you a sort of a condition which we will work with. Aij is equal to 1 by 2 I minus 3j. Now we are asked that we need to make a 2 cross 2 matrix using this condition. Okay, so now that we are asked to make a 2 cross 2 matrix, we need to understand that what is the basic representation. I just told you that we write a matrix as Aij with the order which will be equal to, now what does 2 cross 2 mean? That it will have 2 rows and it will have 2 columns, isn't it? it will have 2 rows and it will have 2 columns. Now how do we denote each and every element? Now we have these blanks, right? We have 2 rows and 2 columns. So now what this element is belonging to? This element belongs to the first row and first column. So we will denote this as A, first row, first column. Okay. So what is this? This element out here, it belongs to my first row, second column. So what will the element will look like? First row, second column. Similarly, this is my element belonging to the second column. This is belonging to my second row and first column. So my element will be second row and the first column. And finally, this element is my second row and second column. So this will be A22. So for constructing the matrix, we must know each and every element so that we can just make a matrix. So what will we do? We need to find A11, A12, A13 and A14 using this condition which I have mentioned here. I will just highlight this so that it will be easy to understand. Yeah. So now just remember that I here is 1 and j is 1, and I will just plug in the values I minus 3j. Right? We have just substituted the value in the condition given to us. Now what will it be? 1 minus 3, this will be 1 minus 3 is minus 2. Now just focus that this is my modulus function, right? So any negative value will become positive. Now what will it be? 2 by 2, which is 1. Okay. So now similarly, focus here that A12 is such that my I is equal to 1 and j is equal to 2. So what will be it? I minus 3 times of j, right? 1 minus 6 is minus of 5. Now when it will come out of the modulus, it will become 5 by 2. Yeah. So we have just calculated A11 and A12. Now for A21. Why are we finding A21? Because that is the next element whose value we have to calculate. Now I is equal to 2 and j is equal to 1. We will just plug in the values. I minus 3 of j, which is 1 by 2, 2 minus of 3, which is 1 by 2, right? Now what is my next element? A22. My I is equal to 2 and j is equal to 2 as well. So what is it? I minus of 3 times of j, 2 minus of 6, which... So now that we have calculated each element in this matrix, now we will just simply write our general form. This is how generally we represent the matrix with the order written in the subscript. Now what the elements were: A11, A12, A21, A22. Now we will just simply plug in the values which we have calculated above. What was my A11? A11 was 1. A21 was 5 by 2. A21 is my 1 by 2. And A22 is 2. So this is how we basically have created a matrix. We have created a matrix using a given condition and by calculating each and every element. So now we have just covered the agenda, what we have covered here. We have covered what a matrix is and how we create a matrix. Now what are the types? What are the types that we have? Types of matrices. So the first and the foremost is that we have a column matrix. Now what do we mean by column matrix is that we know that every matrix has a order m cross n, where m is the number of rows and n is the number of columns. Now in a column matrix, the number of rows can be any number of rows, and the number of columns, it will always be 1. Now what do I mean by that? I will just give you an example. 2, 3, 1. Now just understand it yourself and write the order of this matrix. What is the order? We have 1, 2, 3. 3 rows multiplied by how many columns are there? Only 1 column. So what is the order? 3 cross 1. So in column matrix we just have a single column, right? Now the next one is a row matrix. In a row matrix, again the condition is the same kind of as in the column matrix. If n cross m is the order, in general order, the number of rows must be 1, while the number of columns can be any number of columns. I will just give you an example. 1, 2, 3. I have a single row, and how many columns I have? 1, 2, 3. 3 columns. So the order is 1 cross 3. Now then we have a zero matrix. Now what do we mean by a zero matrix is that, for example, I have a 2 cross 3. Let me just consider a 2 cross 3. It means 1, 2, 3. I have 2 rows and 3 columns. Now every entry in this matrix will be 0. Every entry in the matrix will be 0. Okay. Now the next is a special kind of matrix. It is my square matrix. Now in square matrix, now since we had the order m cross n, now the additional condition in a square matrix is that m is equal to n, that is number of rows is equal to number of columns. Now I will just give an example. What if I am dealing with a 2 cross 2 matrix and a 3 cross 3 matrix? How will it look like? Okay. So in a 2 cross 2 matrix, let us assume this is my matrix. I have 2 rows and 2 columns. This is 2 cross 2. And in 3 cross 3, let it be like this. I have 3 rows and 3 columns. The order is 3 cross 3. So it's just this basic thing that the number of rows will be equal to the number of columns, right? Now in a square matrix we have further divisions. There are 3 types of square matrix. The first one is a diagonal matrix. The next one is a scalar matrix. And the last one is an identity matrix. Okay. So now before proceeding, just understand what do we mean by diagonal elements. Now diagonal elements are basically present when the number of rows is equal to the number of columns. Okay, that is when we have a square matrix. Now as I have just considered above this example 6, 3, 1, 5. So now consider this consider this as if this is a square. What is the diagonal? This is my diagonal, right? So this we call it as diagonal elements, while the rest, this one and these two are non-diagonal elements. This is also my non-diagonal element. So this is what generally we mean by a diagonal elements. I will just explain it 3 cross 3 as well for the sake of completeness. This is my matrix which I have just written above. Okay. So this diagonal will give my diagonal element, and the rest are non-diagonal elements. Okay. So now let's just jump into what my diagonal matrix is. What do we mean by diagonal matrix is that it just means that the non-diagonal elements must be 0. What do we mean by that? For example, I have this matrix. Now this is my diagonal elements, right? I have just explained above. Now these two are my non-diagonal elements, so these will be always 0. So this is what a diagonal matrix means. Okay, now the next one is my scalar matrix. In a scalar matrix, what we have is that the condition is the same as my diagonal matrix. Here again we will just what the additional condition is that the diagonal elements must be equal to a number. Now that number has to be the same. What do I mean by that? Let us consider a 3 cross 3 matrix. Now along the diagonal, the number will be the same. Like here I am considering 2 and the non-diagonal elements will be 0. Okay, now the number that we have here, like in this example it is 2, it can be any number. Okay, I am not constraining that it has to be only 2. In general form, if I were to mention it, this is my matrix. Now here m is equal to n. Along the diagonal it will be a k constant, otherwise it will be 0, because this is my non-diagonal element and this is my diagonal element, right? I hope so this is clear, like what my diagonal elements look like: a11, a22, a33, right? So this is how in general terms we can just write a scalar matrix. Now the final type is my identity matrix. Now in identity matrix, it is a kind of a scalar matrix, but the additional condition is that the scalar k, which I have just written above, it has to be 1. For example, this is my 3 cross 3 matrix. The constant along the diagonal is equal to 1, while the rest of the non-diagonal elements are 0. So this is an example of a 3 cross 3 identity matrix, but if I were to consider a 2 cross 2 matrix, along the diagonal it will be 1 and the non-diagonal elements will be 0. Okay, so I hope so this is clear. So the final thing what comes into our mind is that when are two matrices equal, that is equality of matrices, when do we talk about it? Now the major important thing is that the order of two matrices must be the same, and the corresponding elements of A and B must be same. Now what do I mean by this? I will just give you an example. 1 2 3 4, this is my matrix A, and I will just consider any other matrix. This is my matrix B. Okay, now is A equal to B? That is our question, right? Now the first thing is to check the order. What is the order of A? It has 2 rows and 2 columns, so the order is 2 cross 2. Again with B, it has 2 rows, 2 columns, the order is 2 cross 2. Yes, it is same. Now are the elements in A and B same? Now just focus that the A11 and A11 elemented, both of them, are they same? This is 1 and this is 2. So the corresponding element in A and B must be same. So as we can see that A11 in A is not equal to the A11 in B, so we will say that A is not equal to B. These two matrices are not equal, even though the rest of the elements like A12 is 2 and A12 here is also as well 2, A21, sorry, this is 3 and this is also 3, this is 4, this is 4. But the aim is that each and every corresponding element that we have in A and B must be the same. Okay, now if I have had the matrix as A2 3 4 1 2 3 4 1 2 3 4, no, it is pretty visibly understood that the order is same, each corresponding element is as well same, right? This is 4 4, then we can say that A is equal to B. Two matrices are equal, right? So this is how we just check whether two matrices are equal or not. If you want to do a question based on this, let us suppose this is my matrix A and this is my matrix B. Okay, now the question is, for what value of x is A equal to B? Okay, now what are the order? What is the order? It is 2 cross 2, 2 cross 2, right? For A to be equal to B, every corresponding element must be same. Okay, so now we can see that we just need to know x, right? So what is x? It is the first row second column element in A. And what is the element A12 in B? It is 3, right? In B. Now for A to be equal to B, my A12, which is x in A, must be equal to 3, isn't it? So what my matrix B will be? It will be 1. Sorry, what will my matrix A will be? A 3 3 4. So this is a very easy applied question based on equality of matrices, like how I have calculated the value of x so that the two matrices are equal. Okay, now the second last agenda is that what are the basic operations in matrices. Now the first one is the basic addition. Now in addition there are two conditions. Like in equality of matrices, the matrices must be of the same order and we add the corresponding elements of the two matrices. Okay, I will give you an example. Suppose this is my A and this is my B. Okay, I want to add these two matrices. I will first of all check whether the order is same. What is the order here? 2 cross 2 and the order is 2 cross 2. I hope so that this is clear by now. How do we find the order of a matrix, right? So first we will just write down side by side what do we want to add. Okay, now just focus on the corresponding element A11 and A11 in both of them and write it down, because we want to add, so we write it as 0 plus 2. Now what is the next one? A12 of A, A12 of B. So what we are doing is picking the corresponding elements and adding them. Okay, what is A21 in A, A21 in B? This is it. I will just pick any other color for the sake of easiness. A22 in A, A22 in B. This is, yeah, I will just simply apply my basic arithmetic property, just add the numbers. Yeah, this is it. Sorry. So this is how basically we add two matrices by simply picking the corresponding elements from the matrix and adding them. So this was in case of a 2 cross 2 matrix. Now what if I will give you another scenario? This is another example. How can we add these two numbers? The first agenda is to check, is the order same? Now what is the order of the matrix A? It has 2 rows and 2 columns. Now what is the order of the matrix B? It has 3 rows, 1 2 3, and a single column. The answer is order is not same. So A plus B is not defined. Isn't it pretty understood that the two matrices cannot be added because the corresponding elements cannot be added, isn't it? So it is very important to focus on the order. First of all, order is an important aspect, after which we just add the corresponding elements. Now let us just come to our next basic operation, which is subtraction. Again, it is the same, it works on the same basis as an addition, is that we have to check whether the order is the same, and we subtract the corresponding elements. As in before, we simply added them, right? Okay, so I will just give an example to you. 1 2 5 7, and my B is 3 4 7 2. First of all, check whether the order is same. The order is same, both are 2 cross 2 matrices. Now what I want to do is to subtract. We will write it. Again, I will just use different colors so that you can understand it better. What is the A11 element here? 1 minus of 3, then A12 element in both of them. This is my 2 minus of 4. We are subtracting the corresponding elements here. I hope so that is clear. Now what is A21 here? 5 minus of 7, and A22 here, it is my 7 minus of 2. Now we will just simply subtract. 5 minus of 7 is 2, and this is 5. So this is how we subtract two matrices. Now again, if the order is not same, right? What if the order is not same? We just simply say A minus B is not defined. Okay, I hope so that is clear. Now the last operation that we will discuss for today is scalar multiplication. Now for scalar multiplication, the order can be any, and what we basically do is we multiply the matrix with a scalar k. What do I mean by that? For example, I have this matrix 2 1 4 5 7 3 and 1 6 7. Just a minute. I'll just write it properly. Yeah. If I have this matrix 2 1 3 2 4 7 3 1 2. Now if I am considering a scalar 2, what will it be? I will just simply multiply it by each corresponding element here. That will be 2 cross 2, 2 cross 1, 2 cross 3, 2 cross 2, 2 cross 4, 2 cross 7. I hope so you are getting it. Now what will it be? We'll just apply our basic arithmetic properties. 4, 8, 2 cross 3 is 6, 6, 2, 4. So we just multiply the corresponding elements. So that this is what do we mean by scalar multiplication. So what have we done overall? If I were to give you a summary of what we just did, is understand what are matrices, what is the order of a matrix, right? What are the types of matrix? I will just add here creation. We just also created a matrix. The types of matrix and the basic operations associated with matrix. Let it be addition, subtraction, and scalar multiplication. Okay, so this is what we have done today. In the next lectures, we will just proceed with the operations in matrices, and we will just focus on the next topics. So I hope so that this is clear to you. Thank you so much.